So next line, as you know, we have discussed the formula of maximum shear stress. Q max is equal to F by I. This already we have derived. F by I into X into D divided by 2. Okay, this maximum shear stress. If you consider the maximum shear force, so stress multiplied by the area, so maximum shear force F max is equal to stress multiplied by area, Q max multiplied by area, which is equal to F by I into that X equal to B. I am putting X equal to B now. So D into B, X into B, that is B into D by 2 into area, thickness into width. Maximum shear force at X equal to B, as we have drawn the shear stress distribution diagram along the width. So maximum is at X equal to B and 0 at X equal to 0. Okay. So that is the maximum shear force Q max into area X in at X equal to B, maximum shear force equal to F by I into B into D divided by 2 into T into B. All of you written?
Yes, sir.
Right. So as we have calculated maximum shear stress and maximum shear force, if I consider the average shear force at point 1 and at point 2, which is I have shown in the diagram, face at point A and B. At A, sorry, at point 1, at 1 X equal to 0, at 2 X equal to B. So I will calculate the average now. Okay, I will calculate the average, right? So now average shear force F average is equal to F1, force at 1, force at 2 divided by 2. So is equal to F by I. Now putting the X equal to 0 and X equal to B in previous equation. So after simplifying, F by I into B square into D into T divided by 2 divided by 2. Okay, equation of F max, you can refer the equation of X max, F by I. Okay, D into X, suppose D into X divided by 2 into T into B. So B square झाला तिथे B square झाला. Previous equation refer करा F max. D into B आहे divided by 2 आहे into T into B. So B into B झालं B square. So D B square T by 2 झालं ते. Okay, so divided by 2, right? 0 असेल तर 0च येणार आहे. 0 असेल तर F1 ची व्हॅल्यू 0च येणार आहे. F2 ची व्हॅल्यू असेल divided by 2. Now after simplifying, so you get F by 4I B square D into T. This is the average shear stress, right? Yes? Shall I proceed? Yes or no?
Yes, sir.
Right. So now average shear stress is known to you. Okay, now if we have to consider the equilibrium equation, right? So whatever the average shear stress is here, suppose if average, sorry, if we consider the average shear stress here, okay, if we consider the average shear stress here, if we are applying or if you are considering the couple, so due to the average shear force and due to the application of this external force, so twisting couple, which will be nothing but F average multiplied by D is equal to F into E. Due to that, we will avoid the couple, one will balancing the other. So whatever the couple due to the, or whatever the moment due to the average shear force, and whatever the couple or moment due to the applied force F, which is at the shear center, so which will cause the twisting couple, so is nothing but F average into D is equal to F into E. So if we are putting the value of F average, so F by 4I into, the system must be in equilibrium and we will avoiding the twisting. So F average is nothing but F by 4I B square D into T multiplied by D is equal to F into E. So F get cancelled. So E is equal to B square D square T, this is your D, divided by 4I. So this is the distance of shear center for this channel section. E is equal to B square D square T divided by 4I. You can see here that E distance, which is the distance which is taken from the shear center up to the midpoint of the vertical web of the channel section. Okay, एवढं तर डिस्टन्स तुम्हाला माहित असणार आहे. हे डिस्टन्स तुम्हाला माहित असणार आहे, कॅल्क्युलेट करता येतं हे डिस्टन्स. सपोज इट इज एक्स बार और राइट, एक्स बार डिस्टन्स कसं कॅल्क्युलेट करायचं माहित आहे, CGMI. Okay, so you have to find out the shear center distance. So for this section, for this case, here shear center distance E is equal to B square D square T divided by 4I. I is nothing but moment of inertia. Right? लक्षात आलं सगळ्यांना? So what we have done, average shear force calculate केला, force आणि already external applied force आहे. So average shear force multiplied by the D is equal to F into E. That will create the couple, twisting couple. We have equated that, and from that we have calculated the shear center distance. E is equal to B square D square T divided by 4I. लक्षात आलं? All of you written? Shall I proceed?
Oh, sir. Yes, sir.
Okay. Suppose some standard section we have considered with the dimension. Some standard section we have considered with the dimension. Suppose this is the section having thickness is T. It's your B. And shear center here located distance is your E, and total distance is taken as your H. So shear center for this case is equal to 3B square divided by H plus 6B. By putting the value of moment of inertia, I value आहे ना खाली 4I वगैरे किंवा जे असेल, तर I is nothing but moment of inertia. जर फाइंड आउट केला आणि ते जर पुटअप केलं तर shear centerचं डिस्टन्स जे आहे फॉर दिस केस E is equal to 3B square upon H plus 6B येतं. जर आपण जर I सेक्शन जर घेतला I am giving some standard cases. Procedure is same. Right, suppose this is your B1, B2 width. B1, B2, these are nothing but the width, left side and the right side. B1, B2. Thickness is suppose T2. Here thickness is your T1. Thickness is your T1. So for this case, it is HS square T1 divided by 4I in bracket B1 square minus B2 square. This will be the shear center distance for this section. Right, B1, B2. दोन चॅनल सेक्शन घेतले इथं आय सेक्शनला. ही आय सेक्शन आहे, दोन चॅनल सेक्शन घेतले मी, लेफ्ट आणि राईट. आणि त्याप्रमाणे जे चॅनल सेक्शनचं इक्वेशन होतं त्याप्रमाणे पुटअप करून यू गेट द व्हॅल्यू. H is nothing but overall depth of section, remember. Yes. लक्षात आलं सगळ्यांच्या? लिहिलात का सगळ्यांनी?
Yes, sir.
Okay. So this is nothing but the calculation of the shear stresses, shear force. Then we have discussed about the shear flow in case of channel section, I section. Then we have calculated the shear center distance for the channel section by using the equations. And E is equal to, we get the B square D square T by 4I. That is standard equation for the channel section. If you consider the dimension by putting the value of I, then we have calculated the E. Okay, then standard I section, left side and right side part, we have considered the width B1, B2. So using the equation for the channel section, okay, putting the values, we have to derive the value of E, right? So this is regarding the your shear center and shear flow. लक्षात आलं?